First problem. A short column of rectangular cross section 80 mm by 60 mm carries a load of 40 kilonewton at a point 20 mm from the longer side and 35 mm from the shorter side. Determine the maximum compressive and tensile stresses in the section. Determine the maximum compressive and tensile stresses in the section. So this is the given problem. So with respect to the given data, we have drawn this section. Now let us move on to the solution part. So in the solution part, first breadth and depth, from that we are going to calculate the area. So area is equal to B into D. So 80 into 60 mm is 4800 mm square. Okay. Next, Ixx and Iy value. So Ixx is equal to BD cube by 12. So B value is 80 into 60 cube divided by 12. 80 into 60 cube divided by 12. It becomes 1.44 into 10 to the power 6 mm power 4. Similarly, Iyy, B cube D by 12. So 80 cube into 60 divided by 12. It becomes 2.56 into 10 to the power 6 mm power 4. Now from the figure, the Ex value is equal to 10 mm, Ey value is 5 mm. That we have to write it down. So eccentricity of load about x axis, that is Ex is equal to 10 mm. Similarly, eccentricity of load about y axis, Ey is equal to 5 mm. Okay. Now the moment with respect to x, mx is equal to p into ex. So p value they have given that 40 kilonewton into ex value is 10. So 400 into 10 cube Newton mm. Similarly, moment about y-axis, that is P into Ey is equal to 40 into 10 cube into 5. So 200 into 10 cube Newton mm. So this is the value of moment about y-axis and moment about x-axis. Now let us move on to the sigma max calculation. Okay, so from the diagram at point C, sigma r is equal to sigma max, such that sigma naught plus sigma bx plus sigma by. So the formula becomes p by a plus mx into y by ixx plus my into x by iyy. Okay, taking all the positive sign. So load 440 into 10 cube divided by area is 4800 plus mx value 400 into 10 cube into y is the perpendicular distance. This is our y value. Okay, and this is our x value with respect to perpendicular axis. Okay, so into y is 40 divided by ixx. So ixx is 1.44 into 10 to the power 6. So this is y value and this is x value. Okay, so this is y and this is x. So here it is mx into y value is 30 into ixx is 1.44. Similarly, my is 200 into 10 cube into x value is 40 x value is 40 divided by iyy is 2.56 into 10 to the power 6. 2.56 into 10 to the power 6. So the value is 19.79 Newton per mm square. So this is the value of compressive stress. Okay, this is our value of sigma max. Okay, next one is at point A. Okay, sigma r is equal to sigma minimum, such that sigma naught minus sigma bx minus sigma by. So here p by a minus m mx into y by ixx minus my into x by iyy. So if we are going to substitute the above values, then we can get minus 3.125. Okay, minus 3.125 Newton per mm square. So this minus denotes tensile stress. Therefore, sigma minimum is equal to 3.125 Newton per mm square tensile stress. Tensile stress. So as per our problem requirement, sigma max and sigma minimum calculated. Now we should move on to sigma at a different position. That is sigma at B and sigma at D is how much. That value also we can calculate now. Okay, let us do. So sigma, that is at point B. Okay, so at point B means A, B, C, D. So x comma y, both are positive, both are negative, and here it is negative, positive, set positive, negative, and here it is negative, positive. Okay, so sigma b is equal to sigma naught plus then plus m sigma bx sigma by. The formula is p by a mx into y by ixx. So here y value is negative, so this is negative. Okay, then my into x by iyy. So the value of P by A is equal to 40 into 10 cube divided by 4800 minus mx. So 200 into mx 400 into 10 cube into y value is 30 divided by ixx. 1.44 into 10 to the power 6 minus my 200 into 10 cube into x value is 40 divided by 2.56 into 10 to the power 6. So the answer becomes okay 3.125 Newton per mm square. So here it is positive, so it denotes that compressive stress. Next, at point D, so sigma D. So here P by A plus mx into y by ixx minus my into x by iyy. Okay, then the value is 13.54. Sigma d is equal to 13.54 Newton per mm square. So this is also compressive stress.